Good morning, class. I'm going to show you how to do the warm-ups from this week, okay? All right, Mondays look like this, okay? Here we have a lot of laws of exponents that we're going to use to simplify this problem. We're going to simplify the numerator first, what's on top. This is a power raised to another power. When you have a power raised to another power, you multiply the exponents together, okay? All right, so here on the top, we have 3. We have 2 times 4, okay? On the bottom, when you're multiplying exponents that have like bases, that means this is the same, these are the bases, you can add these exponents together. So on the bottom, what you have is 3. This first exponent is 2. The second exponent is 3. So we're going to add together. Look at the difference between multiplying when you have an exponent raised to another exponent and multiplying when you have exponent base times exponent base, okay? The bases are alike, add the exponents. So on the top, this is what we have, 3 to now the 8th power. And on the bottom, you have 3 to the 5th, okay? The last thing that you need to do when you divide is you subtract the exponents. So you have 3, you have 8 minus 5. So 8 minus 5 is 3. So our answer is going to be 3 to the 3rd power. Okay? All right, Tuesday, we're evaluating again. We're going to simplify the numerator first and then the denominator, okay? All right, so when you simplify, you can only multiply where the bases are alike, so you can only do these two. This base is not like the others, so you can't multiply those together in that way. So you have 4 is being multiplied 5 times, so you're going to say 5 plus that negative 3 times, and we're just going to leave 5 to the 4th. On the bottom, these two have the same base, so you can multiply those together. When you multiply exponents with like bases, you add the exponents. So I'm just going to write this as 4 to the 4th power. And I got times. And you have 5 as your base. And you're going to add 6 plus a negative 5. So on the top here, this gives you 4 to the 2nd power times. This gives me 5 to the 4th. And here, this gives me 4 to the 4th power. And this gives me 5 to the 1st. Okay? Now let's simplify by dividing. So when you divide here, you're going to subtract 2 from, you're going to subtract 2 minus 4. So we got 4, 2 minus 4, and we got 5. We got 4 minus 1. 4 minus 1. So I'm going to use this space down here. So what this gives me is 4 to the negative 2 power times, this gives me 5 to the 3rd power. Okay? Because you have a negative exponent here, in order to make it a positive exponent, you move it to the bottom of a fraction. So that's what we're going to do. We're going to move this to the bottom of a fraction, 1 over 4 to now the 2nd power. And then we got times 5 to the 3rd. Multiply straight across. You can make this into a fraction. And this gives me 5 over 3 divided by 4. Well, I said 5 over 3, sorry. 5 to the 3rd power divided by 4 to the 2nd power. And you can leave it written as an exponent, or you can simplify by saying 5 times 5 times 5, okay, and figure out what that is, 125. And then you go 4 times 4, which is 16, and you can divide, or you can just keep it in exponent form. Okay, so Wednesday is ordering from least, the smallest, to the greatest, okay? So let's look at these. All right, so let's look at place value. Well, let's look, all of these are written in scientific notation. This number in standard form is going to be or back to its original state is going to be where I move the decimal 5 times. So this is going to be 3, and I'm going to move that decimal 1, 2. Well, let me put the 3 here. Sorry. It's a decimal. 1, 2, 3, 4, 5. So I'm going to put 0 as placeholders. Now I'm going to do this one. This is 6. Oh, well, let's write this number out. So we have 3, 3, 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Just to make sure. 1, 2, 3, comma. All right. So now this one, I'll do the same thing. We got 0.7. Move the decimal 3 times. 1, 2, 3. Put 0 as your placeholder. So this is going to be 6, 7, and 2 zeros. Okay. This is going to be 7.2, and we're going to move it 2 times because the exponent is 2. That's where I'm getting the moves from. I'm getting them from this, okay? So I'm going to move it 2 times. 1, 2. 1, 2. So this is going to give me 720. And the last 7.2, I'm going to move it 3 times. 1, 2, 3. So this gives me 7, 2, and 2 zeros. All right, so here, from least to greatest, the smallest number is going to be the 720, which you can see that the smallest exponent was 2. So that's a key indicator that that's the smallest number. So this one is the smallest. So this goes first as 7.2 times 10 to the second. That's first. All right. Okay, the next one, the next to the smallest number is going to be this one right here. Now notice these two have the same exponent. Okay, so they are in the same place value as you see. Both of them are, this is 6,000, this is 6,700, this is 7,200. Okay, so if the exponents are the same, then I know that this one is smaller because this is smaller. The 6 point so-and-so is smaller. So that's going to be the next one. 6.7 times 10 to the third, and then right after it is going to be the 7.2 times 10 to the third. Okay, so then the last one, of course, is going to be 3.3 times 10 to the 5th power, and it has the highest exponent. Okay, so it's not just good enough just to look at the exponents to see which is the smaller or larger exponent, because what if they are the same? If they are the same, then you have to go to the numbers and see which number is going to be the smallest if we're looking from least to greatest. So this is going to be your answer. Okay? Have a good day.